Welcome back to some more geometry. Today we are talking about slopes and equations of lines. So, kind of think about slope, think about what does slope mean. We kind of talked about it before in class as far as previously in other topics, but in other chapters, but let's look at slope. So, the official definition is the ratio of vertical change to the horizontal change. In real world, we call that rate of change. So what it's saying pretty much is like, how much am I going up and down for every time I'm going side to side? That's what we're looking at right here. So the up and down over the side to side change. Now, if you remember these ones and twos, all that represents is just the first set of XYs and the second set. It's just to tell them apart. Other than that, they're just numbers, X's and Y's. So as we go to set it up, let's kind of try this first one together. We have negative 14 and then minus. Now remember, this minus sign is part of the problem, okay? Don't get that confused with the negative on a number. So it's negative 14 minus a negative 7. Sorry, that's a 1 right there. A negative 7 over a 7 minus a 5. So because we have that minus a negative, that right there will adjust itself, giving us the answer negative 7 over 2. Now that's a perfectly acceptable answer. And that's all right having a fraction. We kind of enjoy that because then it makes it easy to go up and down. So in this particular problem, let me go back a little bit. We will go down 7 units for every 2 units we go in the positive direction. Now, if you take a time to do this on your own, hopefully you get the answer 2 over 5. Now, just like before, this is our 2s, these are our 1s. So we'll start with the y2. We got negative 1 minus our y1 over negative 2 minus a negative 7. You get 2 over 5. So the question was asked, what happens if I do them backwards on accident? Oh, let's see what happens. So if we do it backwards, let's say we put the 1s first. We got negative 3 minus a negative 1 over negative 7 minus the negative 2. Well, let's see what happens. So this will change. That'll become positive. So we get a negative 2 over a negative 5. But either way, look at that. A negative over a negative switches to positive. We still get the same answer as long as, if you're going to switch them both. So switch the y2, the y's and the x's. Now, sometimes the only way you can really mess it up is if you switch one but don't switch the other. But you should get the same answer regardless. So when we look at our lines, there's 4 possibilities of the type of lines we have. We have a positive line, a negative line, a 0 line, and an undefined slope line. So these are the 4 different slopes that exist. So if you look on here, this is a negative. This is a positive, and so is this purple one. It is a positive as well. And then if we look at the blue one, that's our 0 slope. And then our red one right here, this is our undefined slope. And we will dive deeper into that here in a couple of slides. Oops, sorry. Adjust my seat a little bit. So, but the meat and potatoes, the main part of this lesson is we're talking about slope, specifically slope of parallel lines and perpendicular lines. So let's look at parallel lines. So parallel lines happen when the slopes are equal. So our 2 black lines right here, we'll call that line A and line B. They have parallel slopes. Now, way we make sure is let's count that. So when you're given a graph, you can actually count the distance between each point, each rise and run between each point that intersects on the grid. So here we go up 1 over 1, up 1 over 1, up 1 over 1. So we can say the slope is 1 over 1. On this one right here, it starts down here at negative 1, but it's still the same thing. Up 1 over 1, up 1 over 1, up 1 over 1. So it still also has a slope of 1 over 1. So they have the same slope, so we call those parallel. So we'll say A is parallel to B. Let's talk about perpendicular lines. So perpendicular lines are a little bit different. So we'll call this C and this one right here D. All right, so these perpendicular lines, the way the perpendicular is if their slopes, the product of the slope is negative 1, but also we call those negative reciprocals. Negative reciprocals. Okay, negative reciprocals. So what does that mean, negative reciprocals? Well, let's see. We're going to start with this. So this one starts right there, and the other intersection's up here. And then for the line C, it's down here. All right. So for line D, we had to go up 1, 2, 3, 4, 5 units, and then over 2. So line D has a slope of 5 over 2. Now, line C, let's look at that. Line C over here, you get to go down 2. So it's a negative 2, and then over 1, 2, 3, 4, 5. 5. So it's a negative 2 over 5. So let's look at these two slopes right here. So we got 5 over 2 and negative 2 over 5. Now, are they negative reciprocals? Well, let's see. So if I take the number 5 over 2 and I make it negative, I put it through the negative cycle, that becomes negative 5 over 2. And then if I do the reciprocal of that, now remember, reciprocal means to switch the position from numerator to denominator. So that becomes a negative 2 over 5. So yeah, these are negative reciprocals of each other. So you'll say, hey, D is perpendicular to C. That's the sign for perpendicular. This is the sign for parallel. So hopefully that kind of helps build this, because you're going to be using that concept a lot in the homework. So right here, one of the practice questions was, hey, what is the slope? Are these lines parallel, perpendicular, or neither? Well, that's a good question. Remember, parallel has the same slope. So same slope. Perpendicular are what we call negative reciprocals, and neither is just they intersect. No uniqueness between them. So let's look at A to B. Now, even though the letters are backwards, it says A to B, we still read it left to right. So to go from B to A, we go up 1, 2, 3, 4, 5, 6 units, and then over 2. So AB has a slope of 6 over 2, or 3 over 1, or just 3. Okay, C goes down 1 and then positive 3. So CD has a negative 1 over 3. And let's compare those. Look at that. They're negative reciprocals. Now, we talked about negative reciprocals they flip them in the negative. But as the official definition says, is they have a product of negative 1. They're slopes. So the reason that happens is because you got negative 1 over 3 times a 3 over 1. So when you multiply, you got negative 1 times 3 gives us a negative 3. 3 times 1, that gives us 3. Negative 3 over 3 gives us negative 1. So that's where the negative reciprocal comes from. So now let's kind of look at another one. So we didn't do this one in class, but I did leave you guys to try to figure out. So this time we don't even have to graph it. Let's just kind of look at this. So we got the numbers. So this is our x. We're going to find the slope of that. Again, to find things are parallel, perpendicular, neither, you find the slope. You find the slope, y'all. So this would be our 2s, or x2, y2 right here. So we'll start 2 minus 6 over negative 9 minus 3. You simplify that, you end up getting negative 4 over negative 12, which gives us a positive 1 over 3. All right, so we got a positive 1 over 3, and then we're going to do C and D. So these are our 1, 1, our 2, 2s right here. So we got 3 minus 4, right? 3 minus 4 over 2 minus 5. 2 minus 5. So 3 minus 4, negative 1. 2 minus 5, negative 3, which is negative, negative. That gives us a positive 1 over 3. And look at that. They're the same. So these are parallel lines. These are parallel lines. So good job, y'all. All right. So the other, that kind of starts the whole equation part. Remember, the first part of this assignment was slope. The second part is equations of lines. So let's look at these equations. So there's two main equations that we're going to deal with. The first one is called slope-intercept. Take a wild guess why it's called slope-intercept. It's insane. Yeah, it's called slope-intercept because it gives us the slope and the y-intercept. Oops, I got those backwards. The slope and the y-intercept, exactly. They will always have those out there, so we can look at the equation and say, hey, my equation starts at this point on the y-intercept, and it has this kind of slope. So, for example, writing an equation in slope-intercept form of a line that has a slope of 3 and a y-intercept of negative 2. So when we write this, remember, the formula is y equals, in this case, would be 3x plus, and it's a negative 2. So when we adjust that for the plus negative, go y equals 3x minus 2. And that's my equation. Now, when it goes to graph it, you start with your y-intercept. The y-intercept goes through the y-line. It goes through negative 2, the value right there. And then we have a slope of 3. But not just 3, it's a 3 over 1. So we go up 3 units, 1, 2, 3, and then over 1. 1, 2, 3, then over 1. 1, 2, 3, over 1. We can go forever and ever. You can also go backwards. So to go backwards, you go negative 3, 1, 2, 3, as long as you compensate for that negative. Negative 1. negative 3, negative 1, negative 3, negative 1. You see that? Nice straight line right there. The other equation is the point slope. Again, mathematicians are super smart, but they weren't the most creative with names. It's called point slope because they give you a coordinate of points and the slope. So in point slope form, let's talk about that. So in the assignment, it's going to ask you to find the equations and slope intercepts. So since we're going to do point slope here, we're going to go on the form, we're going to use this form, and we're going to substitute these numbers. So this is my x1, this is my y1, and of course that's the slope. So we're going to just plug those in. So we got y minus a negative 5, well, minus 5, equals negative 3 over 4, parentheses x minus a negative 2. So we'll fix that. So y minus 5 equals negative 3 over 4, parentheses x plus 2. Now though, we're done. We're good. That's the equation. You can even graph it from there. Negative 2, positive 5, 1, 2, 3, 4, 5. So I know I got to go through this point. And I have the slope negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4. You continue 1, 2, 3, 1, 2, 3, 4. Connect the dots. They are make a nice little line. But in this equation, they're going to ask you, hey, I want the answer in slope-intercept form. Back in this form right here, you say, well, I don't got the right part. Well, you do. You're actually already kind of there. Where, as you can see, all you got to do is got to move this over here and distribute that. So let's do that. Let's convert this equation into a point slope. So we're going to distribute that, or a slope-intercept, sorry. Slope-intercept. So we distribute that right there, and then we're going to just multiply that. So we got y minus 5 equals negative 3 over 4x, and then minus 6 over 4. If you remember, again, it's over 1. So you multiply top with top, bottom with bottom. All right, so we can simplify that, and we will here in a bit. We're going to go ahead and just kind of get the ball rolling on getting it closer. So the only other thing we got to do is get rid of this 5 with the y, so we added to both sides. Now, as it is right now, we can't add 6 over 4 with 5, so that's over 1. So to do so, though, we need a common denominator, the common denominator being 4. So we multiply the top and the bottom by 4, we end up getting 20 over 4. Now, this number can combine with that number. So this got replaced by the 20 over 4. So now we're left with y equals negative 3 over 4x, and then negative 6 over 4 plus 20 over 4 gives us a positive 14 over 4. Now this does reduce, so we'll go ahead and reduce it. And we get y equals negative 3 over 4x plus 7 over 2. It's okay to have fractions in your problem. Totally okay. There's nothing wrong with that. So don't be scared of fractions. They're harmless. Actually, they're a lot better than decimals, personally. All right, try that again. So here's another problem. Same thing. We're going to start in our point slope form and then turn that into our slope intercept form, because that's what ultimately they're going to want in the problem here. So that's the goal, to get to this knowing this. So as we plug the things in, we got y minus 8 equals 2 slope, parentheses x minus 3. So we distribute our slope through. We got y minus 8. Ooh, it's about 8. There you go. 8 equals 2x minus 6. And again, all we got to do is take care of this 8 right here. Plus 8 plus 8. You're getting y. It's a weird y. There you go. Y equals 2x plus 2. That's what you should have got, hopefully. And when you go to graph that, we start at positive 2. We have a slope of 2 over 1. 2 over 1. 2 over 1. Again, we can go backwards. Down 2 over 1. Down 2 over 1. Down 2 over 1. All right. So the last couple things right here. We said we're going to talk more about horizontal and vertical lines. Like we said earlier, horizontal lines have what we call zero slope. Zero slope. So let's see why. So let's take these equations right here. These points on this horizontal line. And let's set them up. So these are our 1, 1s, our 2, 2s. So we take our y2 minus our y1 over x2 minus x1. You put it together, get 0 over 8, not just 8, negative 8. Now, 0, actually it's positive 8. I lied. There you go. This switches to positive. 0 divided by 8 is 0. So that's why it's 0 slope. Now, and it's because there is no vertical change for all the horizontal change. So that's why it's 0. And 0 is a value. It just has no 0 change. Now, this vertical line, let's talk about that. It's a bit different. We call that undefined. Undefined. But we also can call that no slope. Now, there is a difference between no slope and 0 slope. 0 means it's possible to change, but it didn't change. No slope means there's no change. You can't do anything about it. It doesn't exist. So let's see why. So same problem. Here's our 1 1s. Here's our 2 2s. So as we set it up, we'll have negative 4 minus 0 over 2 minus 2. So negative 4 minus 0, negative 4. 2 minus 2 is 0. What's the problem here, y'all? What's the problem here? That right there. You cannot have a 0 in the denominator. You put a 0 in the calculator, you do negative 4 divided by 0. Either you're going to get error, undefined, or it might just blow up. Who knows? But you cannot try to divide by 0. That's something that's been stressed for as long as I've known is you cannot divide by 0. Now, it doesn't mean you can't graph them. So as you can see, we do have graphs for those. So this is the equation for graphs. For a horizontal line, it's y equals negative b. And for a vertical, it's x equals a. I said negative b, but it's just b. It could be any number. For example, like y equals negative 6 and x equals 3. So for example, let's take those two right there. So we'll do the x in red right here. So the x in red. So where on this graph is the value of x3? Right there. But it's also right there. And it's also right there. And it's also right there. All these values right here, the value of x is 3 on all these little coordinates. That's why it creates a vertical line. Because it's talking about every single possible value of x equals 3. And it's right up and down. These are the intercepts right there. Same thing with y. Y equals negative 6. Y equals negative 6 at 1, 2, 3, 4, 5, 6. Negative 6 right there. But also right there, also right there, also right there, also right there. So that's why it creates a horizontal value, because these are all the possible values of y equals negative 6 directly across like that. So that's how these equations are formed. All right, so now looking to the last part of this assignment. All right, so like we were saying earlier, the last couple of problems on the homework is going to ask you to write an equation in slope-intercept form, either a parallel line or a perpendicular line. So let's look at this first example, and then we got a couple more after this one. So it says, hey, write an equation in slope-intercept form, so we want our equation to be y equals mx plus b form. Of a line that is parallel to the given line, so this is the given line, but our line is going to contain negative 3 and 6. So already we have a point and we're going to need the slope. So that's a point slope form. We're going to start with that and then turn it into slope intercept form. Now it tells us, hey, it's going to be parallel to this. So what information do we need from this? Well, we need the slope. Yeah. Our slope will be the same because it's parallel. Remember, parallel means the exact same slope. So when we set this up, we'll have y minus a negative, or y minus 6 right here equals negative 3 over 4 parentheses x minus a negative 3. So it makes it a minus negative 3, makes it a positive 3. We will distribute that through. So we get y minus 6 equals negative 3 over 4x and then minus 9 over 4. That minus 9 over 4 right there happens negative 3 times 3, negative 9. Now, just like before, we're almost there. We got to just add the 6. But adding the 6 kind of becomes a little problem right here, y'all, because they're not the common denominator. So we multiply both sides by 4. 4 and 4. 4. Okay. We do that, you get 24 over 4. And then that right there, that can go ahead and add to positive 24 over 4. So we're replacing that. We got y equals negative 3 over 4x. My e's keep running out right there. And now it's 24 minus 9, positive 15 over 4. And that's a perfectly nice answer right there. Let's do that again, but this time with the perpendicular. So same idea. We want the equation in y equals mx plus b form. But our line will now be perpendicular. Now remember, perpendicular means what? Negative reciprocal. So this is the line that we're going to be perpendicular to. So its slope is negative 3. So our slope, we're going to take it through the big combine, big machine here. So we take that -3. We're first going to make it negative. What's the negative of a -3? A +3. Then we're going to do the reciprocal. This is the question that I was asked. Like, well, what's the reciprocal of a whole number 3? Remember, all whole numbers have a denominator of 1. So now that we see that, like, oh, that's easy. We just flip it. 1/3. That's the reciprocal here. So our slope that we're going to be using is 1/3. That's the slope that we are going to use for our line that we were perpendicular to the given line. So when we set it up, we got y minus 0 equals 1/3 parentheses x minus 4. Now the cool thing about having a 0 for a y value, it just drops. So we got y equals. So we're set. All we got to do is distribute that and then set it up. So 1/3 times x, 1/3 x. So that's our slope now, 1/3 x. And it's minus 4/3. This is our y-intercept. And we're done right there. All right. 2 more problems. I'm going to leave these here. Maybe you guys can figure it out. I'll kind of set it up for you a little bit. So same idea, perpendicular. So our slope will be 1/2. Here it's parallel. So our slope will be the same. But pause, try yourself, and I'll kind of work this out. So same idea here. Those are the points. We set up the exact same way. Y minus 2 equals 1/2 parentheses x minus 3. We distribute that through. We got y minus 2 equals 1/2 x minus 3/2. And just like before, we're going to add the 2 plus the 2/1. Got to get a common denominator of 2, so we're dealing with 4/2. We put those together. Our final answer is y equals 1/2 x, and then negative 3/2 plus 4/2 is 1/2. Positive. Bam. Perpendicular right there. Good job, y'all. Let's look at our parallel one using the same slope here. We're going to set it the same way. We got y minus 5 equals 4, parentheses, x plus 1. Same thing. We distribute that through. We got y minus 5 equals 4x plus 4, and then we add 5 to both sides. Y equals 4x plus 9. A couple more examples there, so hopefully that helps. You guys have a great rest of your day, and take it easy. Bye.